So you can see that a discrete time linear shift invariant system has an impulse response h of n, with h of 0 is equal to 1, h of 1 is equal to -1 and h of 2 is equal to 2, and it is 0 otherwise. The system is given an input sequence x of n with x of 0 equal to x of 2 equal to 1 and 0 otherwise, full stop. The number of non-zero samples in the output sequence y of n and the value of y of 2 are respectively. Option A is 5, 2, option B is 6, 2, option C is 6, 1 and option D is 5, 3. So the same data which is given regarding that of h of n and x of n are given in the board, okay, in the form of the sequence representation. Now we have to find the value of y of 2. Simply we can use the tabular method. So x of n 1, 0, 1, 1 minus 1, 2. So you can fill the table. So 1, 0, 1, minus 1, 0, minus 1, 2, 0, 2. So you can add all the diagonal values. So we can write it as 1, minus 1, 3, minus 1, 2. And the arrow comes here. Now you see, what is the value of y of 2? Y of 0, y of 1, y of 2. And what are the number of non-zero values? 1, 2, 3, 4, 5. 5 non-zero samples. So here it is 3 and the number of non-zero samples is equal to 5. So the answer is 5, 3. Option D is the correct answer. Right, so given the finite length input x of n and the corresponding finite length output y of n of an LTI system as shown below. So the arrows which is given in the particular secondary screen or the PPT might not be so clear. So please consider the arrows which are given here. The impulse response h of n of the system is dash. So we have to find the impulse response h of n. Option A is 1, 0, 0, 1. Option B is 1, 0, 1. Option C is all ones and option D is 1, 1 and 1. So in this case, the input is given and the output is given. We have to find the impulse response. The number of samples of the input is 2. The number of samples of the output is 5. So L is equal to L1 plus L2 minus 1. So 5 is equal to L1 which is 2 plus L2 minus 1. So we'll get the value of L2 as 4. Now you can see the options here. There are only 2 options where the length of the samples of the impulse response is 4. In the remaining 2 options, which is B and D, in both the options we have seen that the number of samples is 3 only. So we can eliminate the options of B and D, yes or no? We can eliminate the options B and D. Now the option in front of us is only option A and option C. So now what we can do? Let us check with option A. Let us check option A with the tabular method. Okay, so I'll consider x of n 1, 1 and h of n, I'll assume that h of n is our impulse response which is given in the option A. So 1, 0, 0 and 1, right? So it is 1, 1, 0, 0 and in fact for symmetry I'll be adding two more zeros, 0 0. So as we can see, the first one is 1, correct? The second sample is also 1, but here it is 0. The second sample, this is 1 minus 1, right? Yeah, the first sample is 1 and the second sample is minus 1, but actually we have 0 over here. Okay, so the actual output you get 0 as a second sample, but here it is minus 1. So option A is false. So therefore the answer needs to be option C. Option has to be option C. The other way of looking at it, this is the first approach of solving the problem. The second approach is that, let us consider, because we know that L2 is going to be 4, so I'll be considering h of n having 4 samples A, B, C, D. I'll be considering h of n having 4 samples A, B, C and D. The lower limit of input is 0. The lower limit of output is 0. The lower limit of impulse response should also be 0. Because we know that LL is equal to LL1 plus LL2. If LL is equal to 0, LL1 is equal to 0, then your LL2 should also be 0. Now again we can go by the tabular method. 1 minus 1 0 0 A B C D. So you'll get A here minus A 0 0, B minus B 0 0, C minus C 0 0, D minus D and 0 0. So what you will be having here is A, then B minus A, C minus B, D minus C minus D, which is equal to what? 1 0 0 0 minus 1. So the value of A is 1. The value of B is equal to A, which is equal to 1. The value of C minus B is equal to 0. So C is equal to B is equal to 1. D minus C is equal to 0. So D is equal to C is equal to 1. And the last one is D is equal to 1. So you can see that all the samples that we have considered A, B, C, D are all 1, 1, 1. So the answer is option C by both the approaches. The approach 1 is that we have checked whether of option A, because we are only having 2 options. We have already eliminated option B and option D because of the fact that here the length of the samples in the case of the impulse response should be 4, but whereas in the case of B and D it is 3. So we are able to eliminate. Now we are having 2 options in which I am selecting one of them, trial and error, and checking whether A is correct or not. I found A to be wrong. So if A has to be wrong, then C should be the correct answer. Or the other approach is that you are considering, because we come to know that L2 is equal to 4, so I am considering 4 samples. I am doing the tabular method over here, and I am finding equating the result to the actual output which is given to us, and finding the values of A, B, C and D. So from the graphical representation of the question which is given here, the x of n is given, and it is given that y of n is nothing but the convolution of x of n with itself, right? So y of n is x of n with itself. The question is to find the value of y of minus 1. Now what we understand here is that x of n is having 3 non-zero samples. At n equal to minus 1 it is 1, at n equal to 0 it is 1, at n equal to 1 it is minus 1. So we are having 3 non-zero samples. We can do the tabular method. 1 1 minus 1 1 1 minus 1 1 1 minus 1 1 1 minus 1 minus 1 minus 1 and 1. So the result you are having is 1 2 minus 1 minus 2 and 1. So the arrow representation, so as we can see, both are converging to this particular point. So h of y of minus 1, the value of y of minus 1 is going to be equal to 2. Y of minus 1 is equal to the top 2. The arrow is given because n is equal to 0 sample is given clearly, right? You can see from the graph that n is equal to 0 sample is pointing towards the of 1, isn't it? Please check the previous graph which is given. So very good, 31 is the correct answer. Absolutely correct. Right, so two discrete time signals x of n and h of n are both non-zero only for the values of n is equal to 0, 1 and 2. It's clearly given in the question that x of n and h of n both are non-zero for the values of n being 0, 1 and 2. Right, for the remaining values of n, the values of x of n and h of n both are zeros. Now it is given that x of 0 is 1, x of 1 is 2 and x of 2 is 1. Now you are also given the values of h of 0 which is 1, and we don't know the values of h of 1 and h of 2. H of 1 and h of 2 is not known, but we know that these are non-zero values. These are non-zero values, right? So we are writing it as x comma y. Now in the case of the output y of n, y of 1 is mentioned, y of 2 is mentioned, but y of 0 is not mentioned, y of 3 is not given, y of 4 is not given. So, but the question here is that we have to find 10 into y of 3. Y of 3 is nothing but b plus y of 4. That is the question. So what we can do here is that as usual, we will be applying the tabular method, because we know there are 3 samples here, 1, 2, 1, and h of 0 is given. The remaining 2 samples are considered as x and y. So now I can consider 1, 2, 1, x, 2x and x, y, 2y and y. So I'll be drawing the diagonals. So y of 0 will be 1. So the value of a is equal to 1. So y of 1 is 3. So y of 1 is nothing but x plus 2 is equal to 3. So I get the values of x is equal to 1. The next one is 1 plus 2x plus y. 1 plus 2x plus y. The third sample is equal to 4. So here 1 plus 2 into 1 is 2 plus y is equal to 4. So the value of y is equal to 1. Right? So this is y of 2. Y of 3 is x plus 2y. Y of 3, which is what I consider as b, is x plus 2y, which is equal to 3. And y of 4 is y. Y of 4 is nothing but y, and the value of y is 1, which we have considered as c. So the value of c is 1, the value of b is 3. So 10 into 3 plus 1, it is equal to 31. If it is not given by default, the sample starts at n equal to 0. No, we cannot take that assumption. It needs to be given for solving the question. Even in this particular question, it is clearly given that x of 0 is mentioned and h of 0 is mentioned. Okay, I'll repeat once again. See, x of n is what is already given in the question, because in the question it is mentioned that the values of x of n and h of n are non-zero for the values of n being 0, 1 and 2. And for the remaining values of n, it is 0. So there will only be 3 samples, x of 0, x of 1 and x of 2. H of 0, h of 1 and h of 2. X of 0, x of 1 and x of 2, all 3 are mentioned in the question. Whereas here only h of 0 is mentioned, x and y are something that we are considering as h of 1 and h of 2. Now even in the case of the output, y of 1 and y of 2 are given, the remaining samples are not given. But what we know already is that the length of the sample here is 3, here it is 3, here it should be 5, isn't it? Here it should be 5. How can x be assumed to be non-zero? That is what I am telling. X is non-zero because it is mentioned in the question. It is mentioned that h of 1 and h of 2 are non-zero. Please read the question carefully. Right? So y of n is going to be equal to a, 3, 4, b, c. So again I am considering that a, b and c are the non-zero values. We are considering like that because of the fact that it is given that here we are having 3 samples, here we are having 3 samples, here we should have 5 samples. Okay, so y of 1 and y of 2 is given in the question. Now the question that is asked for us is that 10 into y of 3, and y of 3 is what we have considered as b, and y of 4. 10 into y of 3 plus y of 4. So as usual we are applying the tabular method. So once we apply tabular method, we are getting y of 0 value, y of 1. So from y of 1, because it is already given to us, so y of 1 is given as 3. And according to the table, it is x plus 2, right? X plus 2 is nothing but the y of 1, right? So x plus 2 is equal to 3, so x is equal to 1. So we found the values of x here. Next, we will be finding y plus 2x plus 1. Y plus 2x plus 1 is equal to 4 according to the output which is already given to us, right? It is equal to 4. Here we will get the value of y to be equal to 1. So the value of x is 1 and the value of y is also 1. Now we are in a position to find out y of 3 and y of 4. So here we can see that the value of y of 3 is 3 and the value of y of 4 is 1. So we are substituting 10 into y of 3 plus y of 4. So 10 into 3 plus 1, it's going to be 31. So we are given a discrete time signal x of n, whose value is mentioned as equal to n for the value of n between 0 and 10, and it is equal to 0 otherwise. So what is given in the question is that y of n is nothing but x of n convolved with itself, right? So y of n is going to be x of n convolved with x of n, and we have to find the value of y of 4. Please try using the tabular method. X of n is given as n. So whatever be the time value, the same will be the value of x of n when the value of n is between the of 0 to 10. So if I am starting with n equal to 0, x of 0 is going to be 0. N equal to 1, if I take the value of n equal to 1, x of 1 is going to be 1. X of 2 is going to be 2. X of 3 is going to be 3. X of 4 is going to be 4. X of 5 is going to be 5. X of 6 is going to be 6, and so on 10. And similarly here also 0, 1, 2, 3, 4, 5 and so on 10. Where is the arrow? Where do we have the arrow? The arrow is present here and the arrow is present here. X of 0, x of 0. So let me fill the table. 0, all zeros in the first row, and here 0, 1, 2, 3, 4, 5, 2 table, 2, 4, 6, 8, 10, 3 table, 3, 6, 9, 12, here 0, 4, 8, 12, 16, 20. So if we can draw the diagonals, this is y of 0 sample, isn't it? This sample is y of 0 sample, y of 1 sample, y of 2 sample, y of 3 sample and y of 4 sample. So my y of 4 sample, is nothing but equal to 10. Y of 4 is equal to the of